I want to thank you for the invitation. It's so great to have an opportunity to discuss the machine learning monitoring tool we built open source. That's very nice. And yeah, today we're going to have a tutorial. And during this tutorial, I'm going to walk you through the steps how I can set up monitoring for a batch machine learning model using Evidently. And I expect that by the end of this lecture, this tutorial, you'll know at least one way how I can set up monitoring for batch model using open source tool. My name is Emily. I'm CTO and co-founder of Evidently AI, where we built an open source tool to evaluate, test, and monitor machine learning model. Prior to that, I worked over 7 years on applied machine learning models development in enterprise segment, and I work in companies like banking, manufacturing, retail to help them develop and monitor machine learning models. So the experience, again, during this time influenced a lot on how we built the tool. So when we say machine learning based service, it's basically a very general concept, at least from technical point of view. The machine learning based service can be implemented in many different ways. For example, during the experiment stage, you can work with the shadow deployment implemented like Python script or Jupyter notebook. Or when you have a batch production model, it can be implemented as a pipeline containing several steps operated by a scheduler like crontab or Airflow. Or it can be a real-time production service which operate under the high load. Another thing is that model can have different feedback loop. It can be an immediate feedback loop or delayed one. I saw very nice examples from the lecture notes on Drift, where we discussed the estimated time to arrival on Google Map with the immediate feedback loop versus the translation service, for example, Google Translate, where the feedback was delayed. The model can operate in different environment. For example, if you take model from the manufacturing process, it can operate in very stable environment. Or when we talk about users' interests in product consumption, it's very volatile, right? And finally, the service criticality can be different. For example, if we take a model from medicine, the cost of each individual error will be very high. And from other segments, it can be just equal to 0, right? So there are a lot of factors to consider. And all these factors influence a lot on how we design the monitoring. I believe there are several things we should take into account while we designing such monitoring. So first is monitoring should match the machine learning service complexity. We do not want to set up a Grafana monitoring for a shadow deployed model, right? So it shouldn't be more complex than necessary. The monitoring should cover all the known risks, but not overload us with the false alerts. It should be simple enough to be set up by a data specialist. I would say this is more or less questionable because in many companies, someone else should take care about monitoring, not the data specialists. However, there are generally a lot of aspects related to data and models quality rather than software itself. And this is why I believe it's nice when data scientists can design such monitoring as well. And often when we work with machine learning based services, they became more and more complex with time, right? And monitoring should reflect that. It should be easy to expand or even replace at some stages where model became too complex to the selected design. So there are a lot of factors to consider here, and I suggest us move to more practical direction. So let us pick up an example. It will be a toy example where we built a regression model to predict the demand for bike rentals. So the task will be to predict how many bikes will be taken to rent, depending on season conditions and weather. So our hypothesis to test is that we want to make sure that machine learning model can help us to optimize the amount of bikes to place in different pickup location for the users. So we will test whether the model can help to optimize this business process. So let us assume that we will have the model, which is implemented, for example, in Jupyter Notebook, and this model will generate output daily. But our feedback loop will be delayed, and we will have the feedback only by the end of the week. So this is our setup, and now I'm going to move from the slides to the code, and we're going to see how we can build the monitoring for this setup. So we're going to quickly build the model and then evaluate its quality and decide how we should set up the monitoring depending on it. Because in most cases, first, when we build a model, we evaluate its quality, we see the quality metrics and generate some expectations on what we are going to have during the production stage. So here you can see a couple of handy links, in particular link to the example I'm going through right now. And let's start. So first of all, of course, I import a couple of standard libraries and quite a lot of things from Evidently. So I'm not dwell on it now, but we will discuss it at the moment we use different models. And I used to not updating a lot of different libraries. This is why I believe it will be nice to switch off some warnings. If you also use some old versions, maybe you will also like it. And now let's download our dataset. This is the publicly available data about bikes rental. And I preprocess the index a bit in order to make it time series, timestamp. So it will be much easier to select parts of data using time. That's how our final dataset looks like. And this is new index date time. So basically we have everything to quickly build the model. So let's mark target prediction and features. Our target count is called count, CNT. Let's call prediction, surprisingly. And let's split features for numerical and categorical group. We will use this later. And I'm going to split data set into two parts. First part for reference, we will use it to train our model. And second part, it will be the current part. We will use it to simulate the production usage of our model. So let's do it on the index-based. January data goes to reference and February data goes to current. And yeah, now we have everything to build the model. So let's take the reference part and split it into train and test datasets using standard scikit-learn function. So here we are. I will just quickly train the regression model. It's random forest, so no need to spend a lot of time on parameters optimization, right? So that's it. And we fit the model. So finally, we need to generate the model's output to our training and testing data. And now we can move to the second step. So our second step is to validate the model on train and test part in order to generate some expectations on the model's quality. We will reuse it to set up monitoring on the next step. So we will use the Evidently to generating a model's quality report. And for doing that, we need to create the final pandas data frame. So we already have the initial data frame with all the features. The only thing we need to add here is target and prediction. So let's do it here, both for training and testing part of the data. So here it is, and we have everything to start making the report. Evidently can parse the data frame structure automatically. So we not really need to create the config every time, but in case you have some categorical features encoded as the digits, it makes sense to tell Evidently explicitly that these features are categorical. It's especially useful in case you're building reports like data drift, because, well, usually we always use different statistical tests, right, for numerical and categorical features, but Evidently parse the type of features automatically based on the pandas data frame columns type. So if it's numerical, then the features is interpreted as numerical. If not, like string or object, then we think it's categorical one. So let's create the column mapping. So we just reused the variables we created before, numerical features and categorical features, and here we are. So now we can generate a dashboard. At the very beginning, we imported dashboard object from Evidently dashboards. So that's how we create the dashboard. And we need to specify which tabs, which parts of the dashboard we build. In this case, we have a regression model, and this is why we build regression performance tab. be analyzing the model's performance. So after we create an object, we need to run calculations, and here we need to pass the data, right? So it's xtrain and xtest. I perform sorting here because we just mixed up it during the splitting the data set, and our column mapping. So basically, that's all what we need to do in order to generate the visual dashboard. And there are two ways how we can visualize the results. First way is to run method show, exactly as I did now. And the second is to run method save and put there the name of the file. If you run save, evidently generate for you interactive HTML dashboard, which you can send over to your colleagues, for example, via email, especially if they're not using Python and Jupyter notebooks. But here we're using method show because we want to visualize the dashboard inside of the Jupyter notebook, and that's how it looks like. So we have a lot of information here. It starts from the tab with metrics, and you can see that the model is pretty good, at least on top of the training and testing part of the data. So our mean error is almost 0. Our mean absolute error is equal to 4.5 bytes. Pretty nice for training. And our mean absolute error on test part is equal to 10. Right, so probably we should expect more or less same quality during the simulation of production usage. And we also have mean absolute percentage error and some visualization here. Let's move there. So we can visually explore how our model works, for example, by comparing predicted values with actual on top of the reference and current data set. And you can see that model was trained pretty well, right? So more or less predicted and actual values are on the diagonal, so that's nice. We can analyze the predicted and actual values in time. So we can see that model able to follow the trend of the target function. And we have a lot of visuals for different metrics like error or absolute percentage error, which is sometimes also very interesting to observe visually. And we have additional plots with the error distribution. So we can check whether our model tends to underestimate or overestimate the demand. In this case, it's pretty symmetric against 0, at least on top of the training part of the data. So this is good news. And we have the visualization of error normality. So we plotted dataset quantiles versus theoretical quantiles, which is also helpful to analyze what is happening with the error. And surprisingly, that's not all. We have some information on the statistics on top of the objects where model tends to underestimate and overestimate the target function highly, right? So top 5%. But I believe you don't need this information now. But if you're interested, of course, later you can explore some visuals and see whether there are some dependency between feature values and model error. Sometimes that's very interesting. So yeah, pretty big report. But now we know what to expect, and we can finally train the production model. I believe it makes sense to train it on top of the whole reference data, right? Because, well, we just trained it on only train part, but for production, let's use all data we have. So let's regenerate our model, and generally, after recreating the new model, it makes sense to estimate the model's performance again in order to at least make sure that we didn't make any technical mistakes or things like that. So let's do it. Let's generate the prediction on top of the whole reference data set, and we can generate the same report again. But during the analysis, we just skipped like the whole last part of the report and didn't really analyze each plot. So probably we should generate a more shorter version of the report. And this can be easily done with help of verbose level parameter. For each tab, we can specify how much details do we want to have in this report. And if we select verbose level equal to 0, our report will be much shorter. So let's do it. And in case you have only one dataset, that's not a problem. We can just specify one dataset and pass the none value for the second dataset. So here we're gonna have the report for built only on top of one dataset and its shorter version. So we have tab with the metrics. We can see that the quality metrics are exactly as we expected. Model works pretty well, and we can see predicted versus actual values. predicted and actual values in time, and a couple more of plots. So that's it. That's shorter version of report. And it's pretty easy to get it. So now we can see that we have our final production model, and we can start simulating the production usage of this model. Of course, when we use machine learning model in production, even batch, we not always want to explore the visual reports on every step, right? We prefer to automate it, and we're going to do that a bit later. But sometimes when we just implement the model for the first time, we want to keep an eye on it for maybe first 2 or 3 weeks visually to make sure that everything works okay. So for now, we are going to stick to the visual reports, but on the second step, we'll automate it. So let's start doing this.
I'm sorry, did you just say like it's like 2 to 3 weeks to like be sure that the model is not doing something crazy?
Yeah, I just selected only 4 weeks for training. Yeah, that's a bit maybe a bad decision for real production model. But later, I believe it will be interesting to explore drift, and in order to see it faster, just decided to like do such kind of seasonal trick here. So yes, the initial assumption is that we have feedback only at the end of the week. So let's generate the output and see how the dashboard looks like. So here is the output for the current data set, and let's again calculate the report. So if we prefer to keep the same dashboard structure, we can just reuse existing object and not build a new dashboard object here. Just run calculate on top of the new data. So let's do it here. We just specify as help of flag which part of the current data we're going to use, and we will take the first weeks of production usage. And again, run command show. So let's see how it looks like. And we can see that, we are interested in the quality metrics on top of current data set, and you can see that mean absolute error is equal to 13.5, so a bit worse than we expected, but still probably in the normal ranges. Here are some visuals, and probably we can conclude that we can continue to use the same model. But again, if we analyze mainly quality metric, maybe we can make our report even a bit more customized. And this can be easily done. For each tab in dashboard, we have a very handy method called list widgets. This method helps us to see which widgets are included in the tab by default. So let's run this method and see the output. So here are all widgets that are included in the dashboard listed, and we can select which ones we want to include in our final dashboard. And it's handy that we already added singular brackets here, so you can literally just copy it and paste in the function. So let's do it. Now we generate dashboard object again because we're changing the structure of the dashboard. Our tab will be still regression performance tab, and instead of verbose level, we're using method include widgets. And here we just list the widgets we want. So I'm going to keep the metrics for both reference and current data, and visuals only for current data because we really do not know to explore again and again some visuals for reference data. So that's how we can customize the dashboard. And we can see that now it's became even smaller, right? Quality metrics. Now our mean absolute error is equal to 15, so it's increasing. And that's how our error looks on top of the current data. And that's pretty much it. So we can see that exactly as we expected, our model became worse, of course, but we literally trained it on top of 4 weeks of January, so we expected that. And let's finally generate the visualization for the 3rd week in order to see how model behaves. And yeah, here you can see that we finally break our model, right? You can see that mean absolute error is really high, much higher than on top of testing part of the data. And we can try to figure out what is happening. And we can see that model really tends to underestimate the demand. We can see that mean error is pretty always is under the 0, it's negative. And we can see the error distribution. We can see that it shifted to the left side, right? It's not symmetric against 0 anymore. So probably the reason is that we really underestimate the demand. But second question is why, right? So what has happened? And I believe you can already guess because there is strong seasonality here, but let's see how we could derive this information with help of some validation. So
can I ask a question?
Sure.
Yeah, so for the like histogram of the error, so you say that it seems to be underestimating. So do you recommend trying to correct for this by maybe manually add value to the prediction to make it closer to the actual prediction, or just actual values?
I believe, if we generalize such cases, I believe it makes sense to like calculate quality metric, implement something with something like alerting on top of the metrics, and if something like this happening, explore the possibility to maybe retrain the model and get the better performance. Or if it's not possible to retrain it like in a very automatical way, maybe it makes sense to generate more additional part of the report, like data drift, target drift, or prediction drift analysis to see why the quality dropped and what can be done. Maybe it's data drift or something like this. So I believe both retraining and deeper analysis could help. Hope I got the question right. So evidently can help only with the one part of this. So we do not provide any tool to retraining, but we can help to dig deeper and see what has happened. For this, we can use another part of dashboard. And for here, I suggest us create data drift tab because it's really very simple. So here I'm going to recreate column mapping because in order to save some resources on calculation, we will create data drift dashboard only for numerical features, just because they are stronger in this data set, but no problems for categorical features here. It will work in a very similar way. So now, instead of regression performance tab, we use data drift tab. And we use the same logic with calculating and showing the report. We calculated on top of the last week, and we can see the data drift table here with the summary information on top of it. So this tells us that basically 5 out of 7 of our features are shifted, right? So that's exactly what we expected because, well, it's like January data versus February data, and it's Europe, so it's already kind of warmer weather in February comparing to January. So let's see what features are drifting. And we can see that all features related to weather, temperature, humidity, wind speed, even months are drifted. And weekday and hour are not, and this is exactly as we expected. It would be really interesting if such features would drift. And we can open up a row for each feature, for example, temperature, and try to see what is happening. So here we have 2 tabs. First is data drift, where we have the green line, which is equal to mean of the feature on the reference part of data. Basically, it's here. The value for temperature is already normalized, and the green zone is 1 standard deviation from mean. So we can see that the gray points, which are values of temperature from the current data set, are much higher than it was during the reference. So it's literally getting warmer. And we can explore the data distribution here, and we can see pretty much the same. The distribution of temperature on top of current data set shifted to the right, so it's just getting warmer, right? This is why we detect drift on top of temperature. And same analysis can be performed on top of all the rest features, and we can see what happens with the data. So here is the information about drift. It's detected and p-value for tests. Now we have the information and the answer of what has happened with the model. Basically, we just trained it on top of the very short period with some specific season. So now we understand that for our production model, 2 things is important. So we really need to get these quality metrics because we based our decision on whether we should continue using the model on the values of the quality metrics, and we are really interested in drift because there is strong seasonality in this task. So let's then customize the report and come up with the final version of it. And we will automate it on the next step. So I just wanted to say that there are really flexible tool and you can customize pretty everything. And if the drift is very important for you, you can come up with your own statistical test and make evidently use it instead of the default one. So basically, we have 3 statistical tests implemented by default. It's Kolmogorov-Smirnov, it's chi-square, and z-test. But for example, you can import from SciPy the Anderson k-sample test, create a handler function. So the API is pretty straightforward. We take 2 datasets, reference and current as the input parameter, and the output parameter is p-value. And that's how we create the handler for this function. And you can create the options. This is also a parameter, more or less object we import from evidently at the very beginning. And the option is the way how you can set some parameters to the whole dashboard, even if you use like 2 or 3 or more tabs. So this parameter will be used in the whole tabs inside of your dashboard. And we are going to see how it works right now. So we specify our own implementation of statistical tests. If we do it like this, it will be used for all features, but you can pass the dictionary here as well and specify statistical tests for each individual feature. In this case, dictionary should have feature names as a keys and function as a value. And you can also specify other parameters like number of beans to use wherever we plot the histogram and confidence level for statistical tests. So let's see how it will be looking inside of the dashboard and the dashboard. So now we know that we want to keep 2 tabs, regression performance and data drift. So we put 2 tabs inside of tabs list. For regression performance, we know that we want to keep only specific widgets. So we keep include widgets here, and we pass the options as the second parameter of the dashboard, and then run calculations again. So
can I just like specify any metric I care about? Or for example, I want to say something like count the number of known value in this feature.
There are yes and no. So for a short answer, easily with help of options, there are limited amount of parameters to specify, but we are adding more and more, which like each second release. But there is another one option. You can like create your own widget, and it's comparably simple. And by creating your own widget, you can basically specify everything.
I think it's another question in chat. Like, is it possible to use evidently for text and NLP or only tabular data?
For now, it's best suited for tabular data. So I would say no, but I need to tell that there are some users who already done it, and they use evidently on top of encoding vectors they created for text. So in this scenario, yes. And maybe if we're talking about the performance dashboards, like just model performance, then yes, but data drift is currently, I would say, not available.
So I think the question I have is like, so in the example you show there are only like 7 features, right? But like companies deal with like hundreds, like thousands of features. And how often does a detect like change actually matter?
Yeah, so when it comes to such a lot of features, I believe it's not that handy to explore the data drift visually, right? Because, well, nobody really wants to like check data drift visually for hundreds of features. And in this case, we can offer 2 ways to handle it. First is to move for profiling instead of dashboard, because together with visual profile, we can generate the together with visual dashboard, we can generate JSON profile, and I'm going to quickly show you it today. So there we have information about the amount of drifted features and all p-values, so we can create some function on top of these values to conclude whether the dataset drift is detected and automatically select like top 5 or top 10 the most important features, probably based on both p-value for drift detected and feature importance if we have such information. And second idea is to like use this feature importance information if we had it from the training stage and create specific report only on top of the important features, like the smaller top, and explore it visually. So I believe both can be handy.
So does evidently have a built-in feature importance?
Currently not, because we're integrating only on top of the data, right? So there is no way to pass the importance to evidently, but we explore different ways to add it. Right now, the only way is to create the customized tab and to pass the importance tab or widget, so both is possible, and insert the information right there.
I see. And it only work with like data frames, or can I pass in a stream of data?
Mostly with data frames. So inside of Jupyter Notebook, we expect you to get pandas data frames. But we also work from command line, and there we work with CSV data. So maybe it will be more handy for production batch models.
Thank you.
Yeah, cool. Yeah, let me quickly show how the how our final tab looks like, and we move to the profiling. So that's the report, right? It's now contained from two parts, regression performance and data drift. And we changed the statistical test, so we can see that p-values has changed, right? And the number of bins as well on the previews and inside of data distribution tab. So that's how options influence the dashboard. Right, so basically that's it. But yeah, you already asked very nice questions about automation and how we can really use it in production, because, well, nobody really wants to generate such dashboards inside of Jupyter Notebook. And I want to suggest the way how we can integrate it with other tools. So I have some examples with ready integrations in our GitHub repo. So we have integration with Airflow, which is a very nice tool, I believe. Integration is Grafana. And now again, for saving some resources, I prefer to show the integration with MLflow, because it doesn't require any database and we can do it really quickly. So to run this code, we need to have MLflow installed. And let me quickly create some login and model profiling. I will keep the same experiment batch, experiment dates, right? And just here, instead of visual dashboard, we are going to build the model profile. So we just imported profile from the very beginning. And the logic is pretty much similar. Instead of tabs, we use different profile sections, again, data drift and regression performance. And we use calculate method to calculate this JSON. And I'm going to show you how it looks like. It's very well structured JSON. And for automation, it's often more handy because you can just derive the value you really need and log it somewhere and then create some alerts on top of values you got. So that's how logged JSON looks like. And for example, we can derive mean year or share drifted feature. Of course, we need to know the structure of the JSON output, but it's more or less logical, I would say, and we have some information in our example and documentation. So that's how we can derive, for example, mean year and share of drifted features. I believe someone might recognize the same digits, right? So the same numbers. And finally, how MLflow can help there. I'm going to use the MLflow tracking. Of course, it's more suitable for experiment stage when we track the model performance depend on different hyperparameters, but for logging, it's also pretty convenient. And here we're going to calculate the quality metrics and log it for later explore it with help of MLflow user interface. So let's create our client. I'm going to run this code in order to, this cell in order to save some time, and let me comment on the way. So we created the client, we set the experiment name, right? And here we created the object for profiling. these two sections. So then we created a very simple cycle on top of our experiment dates, and we just log the begin and end of the week because, well, we need this information. Then we run calculation of the profile on top of the part of our current data related to these selected dates, and we derive the values for metrics, mean year, mean absolute year, and drift share from here. And finally, we just need to log it into MLflow. And I printed out some running information to see what is happening actually. And we can see that we have 3 successful runs and everything is logged in MLflow. So finally, we just need to open MLflow UI and see what has happened. So we can open it either directly from Jupyter Notebook, but I do not recommend it because it will lock the notebook, right? And this is why I go to the terminal and just run MLflow UI command. It should open a tab in my browser, so it takes some time, but it should be comparably quick. Yeah, here it is. So here is the link. I will probably open it like myself, and here it is. Now interface is loading. And our experiment, yeah, let me check again how I called it this time. Model quality evaluation. So let's open it. Yes, and we can see that we have all our 3 successful runs there. We can conclude that probably our data was drifting from the very beginning, from the first week of production usage, and that's our quality metrics. Mean year and mean absolute year, so they are equal to what we had during the production usage. And of course, beginning and ending of the day. So this is how you can integrate evidently with other tools in order to automate the models monitoring. And that's pretty much all I wanted to share with you today. So I hope it will inspire you to create monitoring for your models even in very early stage when you have, for example, shadow deployment, because sometimes it's comparably simple using open source tools. Well, thank you so much.
Yeah, thank you so much. My quick question. So I think I use evidently in Jet and I really awesome widgets, right? Then how do I share it with my coworker?
I believe the most straightforward way is to generate the standalone HTML report. For doing this, instead of method show here, we use method save and put here the name of the file. It will generate the standalone HTML report and you can just send it over using any channels. Or the other way is to use some external tools like MLflow or maybe Grafana. We have both integrations as an example, and if you serve it somewhere, you can just log the data with help of Evidently, and everybody can go to the visual interface of Grafana or MLflow to explore the result.
Yeah, thank you. And in your experience, what are the features are most requested by the users?
Mm-hmm. Sorry.
I'm sorry. I mean, in your experience, what are some of the features that most requested by the users?
Yeah, now I got it. So we have really a lot of different requests. So the funniest one is to create some options to set up the color schema because, well, somebody already wanted to change the red to yellow or stuff like this. But if you go to the if I answer seriously, then we need to work on our performance because there are a lot of companies who operated on top of bigger amounts of data and they want to create such reports much faster and to make them more lightweight. So we are going to support some bigger data sets pretty soon.
This is really awesome. I think it's just so I think Hamo a few weeks ago was talking about the deviations from TFX, and it's was talking about how very hard it is to interpret the results. But it seems with the standard deviations, but also for standard deviation stuff, is this only useful if it's normal distributions, or do you think it can be useful for other distribution as well?
I think sometimes if you know like that the features, for example, should be that some specific features has specific distributions, it makes sense to like account for it, because well, yeah, it's something that can pretty often happen. And yes, in this case, I think it makes sense to use another distribution. I should say now we do not have anything like this built into Evidently, so the only way is to create the own widget. But from the other angle, if you, for example, analyze the data drift, I know that it's the very specific tab and it's just related to data drift, but now we're using only statistical tests that doesn't require any specific distribution of the features. But if, for example, you know that your features are having some specific distributions and, for example, mean value is very important, then instead of like general Kolmogorov-Smirnov, you can implement the test, for example, to compare the means or median values or something like this, if it makes sense to some specific features. I believe it also can help.
Thank you so much for this really great tutorial. It looks like it's really nice to use, easy to use, and I think it's very customizable as well.
Thank you so much. Thank you for the invitations and for very interesting questions. I'm really happy to share and to get some feedback with help of questions or other channels. So just want to mention again that it's open source. So if you're interested in the code or more examples, we are happy to discuss and show whatever we have.
Yeah, thank you so much.